So in this video, actually, I'll discuss Octa number 21, paper 2, variant 3. Only one question, that's the first question. Okay, Octa number 21, paper 2, variant 3, the first question. I did this in class, but actually, I think some of you are still having trouble. So the first part, they're saying, draw the graph of y is equal to modulus x minus 5. So you know how to do it very easily. We have done it a lot of times in the class. Y is equal to modulus x minus 5. Then y is equal to 6 minus modulus 2x minus 7. This is actually the tricky part of this question. So when graphs involving modulus, most of the time, like what we have faced, basically the whole function is under modulus. So what do? You actually draw the, let's say y is equal to modulus x minus 5. I just draw the graph of x minus 5 first. So when x equal to 5, y equal to 0. When x equal to 6, y is equal to 1. 6, y is equal to 1. When x equal to 7, y is equal to 2. So actually, this is the graph. It is going in this way also. It will touch at minus 5, y-intercept. Now, when I do the modulus, what I do is that the part below the x-axis, only that part I just reflect along the x-axis. I just reflect along the x-axis. Then the graph will become like this. Okay. So basically, I just draw the graph of modulus x minus 5. Then with modulus, the part below the x-axis, I just reflect along the x-axis. The part below the x-axis, I just reflect along the x-axis. Okay. Then, but this is a bit different because the whole graph is not under modulus. It is 6 minus modulus 2x minus 7. This is also nothing difficult. I can take a few values and actually do it, but it will have a sort of a vertex. Okay. A vertex. So you actually have to be more careful about it. So I can actually break it down. So I can, this relatively more complicated graph, I can form for more easy graphs. For example, y is equal to 2x. So this is how I'm breaking it down. So y is equal to 2x minus 7. Let's draw that, look at that first. Then modulus 2x minus 7. Then y is equal to minus modulus 2x minus 7. Okay, so 2x minus 7 we know how to do. Then modulus 2x minus 7 we know. Then you have minus modulus 2x minus 7. And with that graph, after you have done this, with this, you'll just add 6. You'll add 6 to get this. We'll add 6 to get this. Okay. You'll add 6 to get this. Okay. So first, let's look at, so modulus 2x minus 7. How is going to look like? How is going to look like actually? So 2x minus 7 we know. And actually, y is equal to 2x minus 7. The modulus is, sorry, the y-intercept is minus 7, or minus 7 they didn't show in the grid. So we'll avoid that part. So, but we'll know that when x equal to 0, y is equal to minus 7. When I do, y is equal to 2x minus 7. So when, let's say over here, when x is equal to 3, so y is equal to minus 1, 6 minus 7. So the x-intercept is at 3.5. When x equal to 3.5, y equal to 0. Like if I put 2x minus 7 equal to 0, x is equal to 3.5, 7 by 2. When x equal to 4, 8 minus 7, so y is equal to 1, 8 minus 7, 1. So actually this is your graph. Okay, this is how the graph is going to look like. This is how the graph is going to look like. Okay. All right. Now, actually, and it's also going in this way. It is also going in this way. Now, when I do modulus, actually, what will happen? So y is equal to modulus 2x minus 7. So modulus 2x minus 7, just this graph is going to be the part below the x-axis, it will be reflected along the x-axis. So when x equal to 0, it was minus 7. I didn't show it here, but you know it. When x equal to 0, y is equal to minus 7. Minus 7 will become what? Plus 7. Minus 7 will become plus 7. Okay. So the graph of modulus is going to be this. Okay. When x equal to 3, 6 minus 7 minus 1 modulus, it is 1. Okay. So this is the graph of modulus 2x minus 7. Modulus 2x minus 7. Now when I do minus modulus 2x minus 7, Now, this part is actually not there. This part is not there. So this whole graph will be reflected along the x-axis. So it's going to go in this way. It's going to go in this way. Like the whole graph is reflected along the x-axis. It will be reflected along the x-axis. This y is equal to minus modulus 2x minus 7. So this way we can do very fast actually once you have practiced it. So y is equal to, now this is what they're asking for. So this is basically this function or this expression plus 6. This expression plus 6. And do keep in mind that this is the vertex. At x equal to 3.5, you have the vertex. So now that is this point where the graph has like a bend. Okay, this is we can call it the vertex. So 2x this point, okay, 3.5, where it is changing in this way, turning in this way. So 6 minus modulus 2x minus 7. So if you add 6 to it, so basically what will happen, the graph of modulus 2x minus 7, the graph of modulus 2x minus 7, simply it is going to, the graph of modulus 2x minus 7, simply it is going to go up by, simply it is going to go up by 6 units. Simply it is going to go up by 6 units. So over here, you had 0. At x equal to 3.5, you had 0. So now it is going to become 6. So minus at when x equal to 0, actually you had what? You had minus 7. Like modulus of minus 7, 7, but then outside you have minus also. So it is minus 7. It will become minus 1. It will become minus 1 actually. It will become minus 1. Okay. So this graph is going to go in this way. It's going to go in this way. Okay. I have to draw in this part also, in this side also. So I can just take a point and do it. For example, x equals 7. So 14 minus 7, it is 7. So 6 minus 7, it is going to be minus 1. 14 minus 7, 7. Modulus 7 minus. So 6 minus 7, it is minus 1. So I can take another point. Okay. It will just go like this. Okay, you can, if you want to, in this side also, you can take 1 or more, 2 more points in order to draw the graph more nicely. Okay, so this is the graph of y is equal to 6 minus modulus 2x minus 7. You can take some values and do it, but this part at x equal to 3.5, you have the vertex. This point is very important. So after, if you this happens when y is equal to 2x minus 7, it is equal to 0. Okay, so this is the vertex. So take 1 or 2 values on this side. For example, when x equal to 0, then y is equal to minus 1. And then take 1 or more values on this side also. When x equal to 7, y is equal to minus 1. If I put over here, x is equal to 7, y is equal to minus 1. So this graph is drawn now. Also label it, because you'll draw another graph over here. You'll draw another graph over here. Okay. So this is the graph of y is equal to modulus, y is equal to 6 minus modulus 2x minus 7. Okay. So so you can take some values and then do it. You have to understand, you have to be careful that at x equal to 3.5, there is the vertex. Okay. And also I showed it like from very basic graph how you can do it, like 2x minus 7, then modulus 2x minus 7, minus modulus 2x plus 7. So sequentially, all these are quite easy. So from one step, we are going to other. At the end, if you add 6, you get the final graph. Okay. So, and also always you can check by taking some values. Most important, just keep in mind about the x coordinate of the vertex. Now this graph is done. Then what about the graph of y is equal to modulus x minus 5? This is very easy. So at x equal to 5, you have 0. At x equal to 6, you have 1. So basically, so this is how it goes. Okay, this time, yeah. At x equal to 6, it is actually 1. So I've given it in 2. So that's a mistake. Let's correct it. This is the previous graph. So when x equal to 5, y is 0. When x equal to 6, so 6 minus 5, 1. So it will be here. Here actually. Okay. And when x equal to 7, you actually have 2. So this is how the graph is going to look like. And it will go down actually, but this down part actually, it will be reflected. This part, it will actually be reflected. Okay. Okay. So when x equal to 0, it is x minus 5 is minus 5, but with modulus, it will become 5. So this is our graph. Okay. This is the graph of, so at x equal to 2 also there is an intersection. Okay. At x equal to 2. Let me draw it a bit more properly, then the intersection point will be clear. Okay, this is the previous graph. So y is equal to x minus 5. So at x equal to 5, you have the it touches the x-axis. So this part we drew. Okay. So you actually draw it in the the scale and this. It will not be difficult. So x equal to 5, the value is 1. X equal to 7, the value is 2. So this part is we did previously also. And here we know that modulus x minus 5, if I put x equal to 0, the value will be 5. Like minus 5 modulus, it will be 5 over here. Okay. It will also pass through this point. When x equal to 2, the value will be 3. Okay. 2 minus 5 minus 3 modulus 3. Okay. So this is the graph. So this part is the graph of 6 minus modulus 2x minus 7. This is the graph of y is equal to modulus x minus 5. The critical part was actually this one. The other one is easy. We have done this before. Okay, now, so after this is done, so let's move on to the next part. So both the graphs are drawn in the same grid. So you have to solve this inequality. You have to solve this inequality. So we know the point of intersection. You have to know the point of intersection. Like when modulus x minus 5 is equal to 6 minus modulus 2x minus 7. And normally we solve this algebraically, which we can do it here also, but it is more lengthy. But from the graph, actually, we can clearly see the points of intersection at x equal to 2 and x equal to 6. At x equal to 2 and x is equal to 6. All right. Okay. Now, modulus x minus 5 is greater. It means what? For what values of x? This modulus x minus 5 graph lies above this graph. Above this graph. For what values of x? This graph of y is equal to modulus x minus 5 lies above the other graph. Okay. So this is the point of intersection. So in this section, we see that the graph of modulus x minus 5 is above. So one value is x is less than 2. Okay. We also see here after 6, x equals 6, they are equal. So after 6, after for x is greater than 6 also, the graph of modulus x minus 5 is actually lies above. So it will be x is greater than 6. So the answer is x is less than, for the solution of this inequality, answer is x is less than 2 or x is greater than 6. Okay.